Hi, I'm Bob. Welcome back to the Stata course on regression analysis and estimation methods. In this video, we will look at how to perform a hypothesis test after OLS regression. The Stata command test performs the f-tests of linear hypotheses about the coefficient estimates. Let's continue to use the course dataset bob.dta. Please download it from the resource link. The do files are also provided. The dataset contains information on the US workers between 25 and 54 years old who participated in the panel study of income dynamics surveys. We regress the log hourly wage on schooling, age, female, and race. Remember to use the idoc prefix in front of the categorical variables. The regression output provides the t-statistics and the p-values for the t-tests against the null hypothesis that the coefficients are zero. The null hypothesis of the t-test is that the coefficient is zero. The two-sided alternative hypothesis is that the coefficient is not zero. The schooling parameter is statistically significantly different from zero at the 0.1% level against a two-sided alternative because of a large t-statistic and a p-value of 0 to 4 decimal places. Its 95% confidence interval does not overlap with the number 0. 1 more year of schooling completed increases hourly wage by 12.6%, or precisely 13.5% on average, holding other factors fixed. Age is also statistically significant at the 0.1% level. Female workers earn around 18% less than their male counterparts on average. And this gender disparity is statistically significant at the 0.1% level. For the race variable, the base group is white workers. Black workers earn about 20% less, and this effect is statistically significant at any conventional level. Asian workers earn 8% more than white workers, but the effect is not statistically significantly different from zero at any reasonable level. It has a small t-statistic, and its p-value is 0.4, meaning that we cannot reject the null hypothesis that Asian and white workers earn the same. We can also use the command test to find the same results as those in the output. We type test schooling equal to 0, and we see the f-statistic and the p-value. The result is identical to the t-test in the output of the regression. Notice that the f-statistic equals the square of the t-statistic. We can simply type test schooling and have the same result. The command test not only tests against 0, but it can also test against other values. For example, to test whether 1 more year of schooling completed significantly increases the wage by 13%, we can type test schooling equals 0.13. We could not reject the null hypothesis because the f-statistic is small and its p-value is 0.4. We fail to reject the null hypothesis that the schooling coefficient equals 0.13 at any reasonable significance level. In addition to testing a single coefficient, the test command can test joint hypotheses. we can test whether schooling and age are jointly statistically significantly different from zero by writing the conditions in separate parentheses. An alternative method to specify simultaneous hypotheses is to use multiple equality operators. Or we can just type the variables one by one after the test command. We reject the null hypothesis that the schooling and age coefficients are jointly zero at the 0.1% significance level. Another thing the test command can do is to test whether two parameters are equal to each other. For example, there were 4 categories of race in the data: white, black, Asian, and other. The white workers are the base group in the OLS model. To test whether the black workers are the same as the Asian workers, we type test 2.race equals 3.race. We find a p-value of 0.0053. We reject the null hypothesis that they are equal at the 1% level. Next, let's discuss another useful command for testing hypotheses. After fitting a model and obtaining estimates for coefficients, we can test the linear combination of the coefficients by using the command lincom, which means linear combination. If we want to know the total effects of education and experience on the hourly wage, we can type lincom followed by schooling plus age. We treat age as a proxy for experience here. We see that the sum of the effects is 0.139. Educational attainments and experience together increase the wage by about 14%. And it is statistically significantly different from zero at the 0.1% level. If we are asked whether the total education and experience effects are 14%, we can use the lincom command to test this hypothesis. We type lincom schooling plus age minus 0.14. The lincom command assumes equal to 0 at the end of the combinations of parameters, so the equal sign is not allowed in the lincom command. It provides the t-statistic and its p-value for the test. In this case, we cannot reject the null hypothesis that the total effects of education and experience on wages are 14% at any reasonable significance level because the p-value is large, 0.9. Today, we have learned to use the test command and the lincom command to test hypotheses. They are useful after the OLS regression to find whether the linear relationship between the coefficients is statistically significant. Thank you so much for watching this video. See you tomorrow on the next topic. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.